The U.S. spy satellite program started in the late 1950s for strategic surveillance of the Soviet Union. The satellite imaging capability became crucial after the downing of the U-2 spy plane and the capturing of its pilot, Francis Gary Powers, by the Soviet Union in the 1960s. Remember that the first ever satellite, Sputnik 1, was launched in 1957 by the USSR. It was the very early days of the space program. Building a space launch vehicle, as well as imaging satellites, required overcoming enormous challenges. The success of these programs was a remarkable achievement by the engineers and scientists. The first U.S. spy satellites missions were named Corona and had the designation KH-1 to KH-4. KH means keyhole. There were more than 100 Corona missions from 1960 to 1972. Later, Corona missions had the capability to acquire images of up to 1.8-meter resolution. The imaging payload on Corona missions consisted of panoramic cameras, making a 35-degree scan in the across-track directions. There were two panoramic cameras arranged in a stereo setup to allow three-dimensional mapping of the scenes. In addition to Corona missions, the KH-7 and KH-8 missions, codenamed Gambit, were aimed at high-resolution imaging of specific target sites. KH-7 and KH-8 used strip cameras with the tilt capability for stereo acquisitions. There were 38 KH-7 missions between 1963 to 1967 and achieved the highest resolution of around 60 centimeters, while there were 54 KH-8 missions between 1966 to 1984 with presumably best resolution of around 25 centimeters, or even better, as certain information about KH-8 is still classified. It is remarkable that KH-8 missions could capture imagery with this high resolution this early in the space era. For perspective, compare this with the satellite imagery commercially available around the world. Just a few years ago, until 2020, the highest resolution satellite imagery commercially available was 30 centimeters from WorldView 3 and WorldView 4 satellites operated by Maxar Technologies. It was the only company around the world offering such resolution. There were also U.S. governmental restrictions to the highest resolution satellite imagery made available commercially. Recently, more companies and satellites are being launched that offer 30-centimeter satellite imagery, like Pleiades Neo from Airbus or SuperView Neo from Suwei, China, while Umbra Space is offering 25-centimeter satellite synthetic aperture radar imagery. This underscores the monumental accomplishments of the U.S. satellite reconnaissance program. The declassified datasets from this era offer invaluable perspectives on Earth's earlier landscapes.